Won't be all that long. So we're going to, let me pick a different color. Let me pick this one. So today we're going to look at X and Y intercepts. Can you see this? I think so. If you have any trouble with vision, either close the door or let me know what else I can do to switch this around. So we're looking at X and Y intercepts. In X and Y intercepts, you are going to use the intersection points of the X and Y axis to graph an equation. So we're just going to use where the graph is going to intersect the X and Y axis, and we're going to throw in a checkpoint too. We'll talk about that in a minute. But we're pretty much only going to use 3 points to be able to graph an equation. With the tables, we usually have sometimes 4 to 5 points, but X and Y intercepts, you only need, for the most part, 3. So using the intersection points of the X and Y axis to graph an equation. That's pretty much what X and Y intercepts are. So, as an example, let's look at a 2x plus 3y equals 12 as an example. So now what I want to do is I want to find, so over here I'm going to make a small t table. I'm going to put x, I'm going to put y. So just make a small t table for x and y intercepts, because there's not a lot of work you have to do in the middle for these. It's relatively a little bit easier. I'm going to put a 0 here, and I'll put a 0 here. Last one will be a checkpoint, and we'll get to that one in a minute. So now, whenever I make these t-tables, it's just like when you have your ordered pairs. I always ask you to label them. Whenever you make these t-tables for x and y intercepts, you want to identify what these ordered pairs represent before we actually start doing the calculations. So now, when your x is 0, what intercept is that? At your table, talk about it really quick. When your x is 0, what intercept is that? At your table, really quick. Whenever your x is 0, what intercept is that? Because you want to make sure you have it labeled on that table. It makes it really simple. So when you get to the ordered pair, you know exactly what intercept it is. So class, which one is it? Y intercept, right? So right next to this box right here, you want to put Y intercept. I'll just put YINT. I have a lot of space. So now, of course, the other one's going to be the X intercept. So when you get the ordered pair, right away you know exactly what intercept it is. Sometimes you get the ordered pairs and forget which one is which. Is it X or is it Y? This way, when you get it, you know exactly what it is. So now I'm going to work out the Y intercept in green. So now it already says I have to replace X with 0. So now I'm going to look for the Y intercept first. So write that out so you know exactly which one you're solving for. Now it's going to be 2 times 0 plus 3y equals 12. And the solving of this shouldn't take as long. 2 times 0, 0. 3y equals 12. Divide by 3 into both sides. So then we have y equals 4. 4. So right away we have our y-intercept. So right when I pull it into the box, I know exactly which intercept it is. Because I already labeled it. I'm trying to cut down the confusion. Now let's go ahead and find the x-intercept. So same thing, I'm going to label it x-intercept. For that one, I know I have to replace y with 0 because it shows me right over here in this box. So I have 2x plus 3 times 0 equals 12. 2x equals 12. Divide by 2 into both sides. So then we have x equals 6. And I'm going through this rather quickly because I don't feel many of you will have issues with this one. But if you know that, hey, hold on now, you're going kind of quickly, this is when you slow me and stop me down. Now, the next one is the checkpoint. Now, You can always graph any line with 2 points and connect it, but that doesn't mean that you graph the equation correctly. So you always want to have a third checkpoint to make sure you've actually done this equation correctly. So down here, put checkpoint. And for your checkpoint, you're going to plug in any value of x that you want to. It doesn't matter the value at all. You just plug in a third point to make sure you're graphing this equation correctly. Let's see here. I'll make it 3. I'll just say 3. So now for the checkpoint, I'll just put it over here. And I would kind of write that labeling before you start to do your algebraic work so you know exactly what you're solving for. So now for the checkpoint, it says that I'm going to make x equal to 3 for the checkpoint. Now we just plug in x for 3, 2 times 3 plus 3y equals 12. I chose 3 because I realized that if I multiply it times 2 and subtract it, I can still divide by 3 evenly. So 6 plus 3y equals 12. Subtract 6 on both sides, so 3y equals 12 minus 6 is 6. Divide 3 into both sides, y equals 2. And now this is going to be 3 and 2 for my checkpoint. So now I have 3 solid points that I'm going to use to graph this equation. So let's see, let's do this here. I never tried this before. Let's see what this does. Oh, that was sweet. How do I get off of that thing now? Oh, I guess I can't. Whatever. All right, so we have our 3 points. We have our 0 and 4. On your paper somewhere, make like a coordinate plane the best way you can so we can just plot these 3 points. So we have 0 and 4. Let me see. How am I going to count this here? It'll be 0. I'll make that 1, 2. These are tiny. I'm skipping 1. All right, that didn't come out too well, but anyway. So here we have 0 and 4 at that point, and then we have, what's the next one? 6 and 0. I'm skipping 1. So 1, 2, 3, 4, 5, 6. This is going to be 6, 0. And then what's that middle point? We said 3, 2. And then 1, 2, 3, 1, 2. Yeah, even though my graph, of course, it's a little funky and not as cute as it should be. You can definitely still see, though, that it comes out to be a linear equation. But you want to have the checkpoint. That's the point a lot of students sometimes just don't do. But if you somehow calculate the intercepts incorrectly, or you flip them and forget that you flipped them, that third checkpoint helps you realize if there's a mistake being made on the graph. This is what we're going to be doing today. We're just bare bones, going back to X and Y intercepts, or just going, well, I know you had it before last year, looking at it again, reviewing it, another way to be able to graph an equation. So I'm trying to just provide you with different ways throughout this unit of graphing linear equations. This is another way. So let me stop this one here.